morning, all of you. Welcome to Sri Jayendra and Zone. Today we are continuing the lecture 3, that is atomic structure. In the lecture 2, we discussed about line spectrum, band spectrum, what are the different spectral lines, and hydrogen spectrum also. Now, continuation to that topic. What is limiting line of spectral lines? So, in any spectral series, the last spectral line is known as limiting line. So, last spectral line is called limiting line. This line will be the spectral line with the highest frequency and lowest wavelength. That is important point. Yesterday already I discussed in the last slide. So, this line will be the spectral line with highest frequency and lowest wavelength. Highest frequency and lowest wavelength is important. Just underline that highest frequency and lowest wavelength. So, I'm underlining it. You also underline your book. All this PowerPoint presentation slides are important. This is just like your notes only. So whatever the slide is there, matter is there in the slide, just note it on your notes, because if you write, it will be easy for you to understand. To calculate wave number or wavelength of the lambda of the limiting line, N2 is taken as infinity in Rydberg's equation. For any series, N2 should be taken as infinity. So if you take for Lyman series, limiting line, N1 is equal to 1, N2 is equal to infinity. Similarly, for Balmer series, N1 is equal to 2, N2 is equal to infinity, and so on. So N2 should be taken as infinity. So a limiting line will have highest frequency and lowest wavelength. That is the most important point. Now let us see example 1. Calculate the wave number and frequency of second line in Lyman series of hydrogen spectrum. So they are asking us to calculate the wave number as well as frequency of second line in Lyman series of hydrogen spectrum. So for Lyman series, 1 by lambda is equal to wave number is equal to 1 by lambda. Wave number is equal to nu bar is equal to 1 by lambda, which is equal to RH into, that is Rydberg constant, into 1 by N1 square, that is 1 by 1 square, minus 1 by N2 square. N2 square because they have told second line. Second line means first line alpha line, second line beta line. So beta line means N2 is equal to 3. N2 is equal to 3. So second line, first line is second, and N1 is N2 is equal to, second line is N2 is equal to 3. That is also called as, second line is also called as beta line. I'm writing here beta line. Second line means here beta line. Alpha line means first transition, beta line means second transition. So applying this formula, you know the value of RH, and you know 1 by 1 square is 1 and 1 by 3 square is 9. So RH by 9. So you can find out wave number. After getting wave number, RH into 1 by 1 minus 1 by 9. So which is equal to 9 minus 1, 8 by 9. RH into 8 by 9. 8 by 9 RH. So you can substitute the value of RH, because here we have to do calculation. Just for your idea I'm giving. And after finding wave number, how to calculate frequency. So frequency is 1 by frequency. So frequency is equal to 1 by time period. Or you can say here second line in Lyman series of hydrogen spectrum. Nu bar is equal to 1 by lambda. So frequency is equal to hc by lambda. Nu is equal to c by lambda. From nu is equal to c by lambda, we can find the formula of frequency. Nu is equal to c by lambda, or nu is equal to c into nu bar. Nu is equal to c into nu bar, because 1 by lambda is again wave number. So nu is equal to c into nu bar. By applying these two formulas, c is equal to velocity of light, that is 10 to the power of 8 meters per second. By applying these two formulas, definitely you'll get the answer. So work out yourself. This is example 1. I'm giving direct answer. So wave number is equal to 9.749 in 10 to the power of 6. And frequency is equal to 2.92 into 10 to the power 15 second inverse. So wave number formula again I'm writing in the here itself. Wave number, to find wave number. Wave number is equal to 1 by lambda, and that is RH into 1 by N1 square minus 1 by N2 square. That is Rydberg's constant. And frequency nu is equal to c into frequency nu. It is not nu bar. So frequency nu is equal to c into nu bar. The nu bar is called wave number. From the first equation, we'll get wave number, and you can substitute frequency also. Nu is equal to C nu bar, that is C into wave number, because 1 by lambda is equal to wave number. So frequency is equal to C by lambda. So this is the answer. I hope you can understand this. Now, next question. Calculate the wave number and wavelength of the limiting line of Paschen series. So here they have given Paschen series, limiting line. For limiting line, Paschen series N1 is equal to, for Paschen series N1 is equal to 3, because N2 is equal to infinity, because it is limiting line. So simple derivative formula, nu bar is equal to 1 by lambda, which is also equal to RH into 1 by 3 square minus 1 by infinity square. 1 by infinity is 0, so RH by 9. So nu bar is equal to 1 by lambda, which is equal to RH by 9. If you substitute the value of RH, that is Rydberg's constant value, straight away you will get the answer. And after finding wave number, you can find wavelength also, that is reciprocal of wave number is called wavelength. So I hope this is clear for you. So nu bar is equal to 1 by lambda, and lambda is equal to 1 by nu bar. So first we have to find nu bar, that is wave number, which is coming around 1.218 in 10 to the power 6 meter inverse after substituting the value of RH, and wavelength becomes 821 nanometers, because you have to convert the wavelength into nanometers, because you'll get the answer in meters, you have to convert them into nanometers. That's all. Next question. Calculate the difference in the wavelength of limiting lines in Lyman series and the limiting line in bracket series of hydrogen spectrum. It's a very simple question. So difference in the wavelength. First we'll find the wavelength of Lyman series. So that is 1 by lambda is equal to, for Lyman, RH into 1 by 1 square, because N1 value is equal to 1, minus 1 by infinity square, that is limiting radius. So this is 1 by lambda, that is also equal to RH into 1 by 1, that is equal to only RH, because 1 by infinity square becomes 0. 1 by lambda is equal to RH, means lambda is equal to 1 by RH. 1 by RH. This is lambda, limiting line for Lyman series. Now bracket series. So you have 4 series, Lyman series, Balmer series, Paschen series, bracket series, and Pun series. So for bracket series, 1 by 4 square, lambda is equal to 1 by lambda is equal to 1 by 4 square minus 1 by infinity square into RH. So lambda is equal to 1 by lambda is equal to 1 by 16, RH by 16, that is 16 by 4R, 16 by RH. So this is lambda, and this is lambda 1, lambda 2. So they are asking difference in wavelength. So lambda 1 minus lambda 2 is equal to 1 by RH minus 1 by RH minus 1 by RH minus 16 by RH. So you'll get the answer as minus 15 by, because RH is LCM, 1 minus 16 is 50, minus 15 by RH. So if they are given the value, you have to substitute the RH value also. So see, without RH substituting value, I'm giving explanation. I hope this is clear for you. You can see the answer now. So it is 135, 1358.9 nanometers. That is 15 by RH value also you have to substitute. Then you can get the answer. So all the calculations I'm not doing, because you are supposed to do the calculations. So only formula wise I'm explaining it. I hope this is clear. Next topic in this chapter, very important topic. So we have completed hydrogen spectrum and Rydberg's equation. Now we will see Bohr's theory of atomic model. So this is the Rutherford's theory. What are the limitations of Rutherford's theory? That was being said by Bohr's theory. It was explained by Bohr's theory. So what is the main topic of Rutherford's theory? According to Rutherford's theory, a moving particle should radiate energy, and if it is radiating energy, it should come close to a nucleus, and the electrons should collapse. The electrons should come and fall into the nucleus, due to which the atom will collapse. But the atom is stable, that he could not explain. So for that only he has given the first postulate itself. The atom consisting of positively charged center called as nuclei, and the electrons revolve around the nucleus in a circular path of definite radius and energy, known as orbits or stationary states. So here they are explaining that the electrons The electrons revolve around the nucleus in a fixed path called orbits or stationary states. As long as the electrons are in this orbit, their energy is constant. Means here itself they showed why the atom electrons are not falling into the nucleus of the atom, because they are revolving around the nucleus with high speed in a fixed orbit, fixed path or definite radius, and the energy known as orbits or stationary states. Only those orbits are allowed for which the angular momentum is of electron is quantized. Now, what is the angular momentum? The angular momentum of electron, as they are moving around the nucleus in a fixed path or orbit, they have angular momentum. They do not have linear momentum, they have angular momentum. And to find the angular momentum of the electron, it is an integral multiple of h by 2 pi, that is mbr is equal to nh by 2 pi. So nh by 2 pi, where n is called orbit number, first orbit, second orbit. For n is equal to 1, it is k shell. For n is equal to 2, it is L shell. For n is equal to 3, M shell, and so on. For n is equal to 1, just writing it on the board, just note it down. For n is equal to 1, n is equal to 1, k shell. For n is equal to L shell, n is equal to 3, M, and so on. So in this way, you get the angular momentum of electron, where n is equal to, it will take the numbers 1, 2, 3, 4, and so on. For n is equal to 1, k orbit, orbit or shell both are same. So fixed path, as the electrons are moving around the nucleus in a fixed path, they are called as stationary orbits. So that's why the electrons will not fall into the nucleus. That is the only explanation given by Bohr's theory based on Rutherford's model. And to some extent, it is 100% right. To some extent, it is right. And so, how the electrons are balancing by not coming to the nucleus, that was given by Bohr. That is, electrons revolve around the nucleus with high speed in a fixed path or definite radius and energy known as orbits of stationary states. So electrons are moving in orbits only, so they cannot go out of the orbits to the nucleus. This is called the explanation of Rutherford's drawback. Next, this is the angular momentum of electron should be integral multiples of h by 2 pi. Next postulate, as long as the electron revolves in the same orbit, there is no gain or loss of energy. Means as the electron is moving in a particular orbit, it has neither gain energy nor lose energy. Its energy is constant. The electron will gain or lose energy only when it moves from stationary orbit to other orbit, that is first orbit to second, or second to third, or third to first, or second to first, and so on. So the frequency of emitted radiation or absorbed radiation is given by nu is equal, that is frequency is equal to delta E by H, which is also equal to E2 minus E1 by H. By this you can say E2 is called energy of higher orbit and E1 is called energy of lower orbit. So if the electron jumps from lower energy orbit to higher energy orbit, energy is absorbed. Similarly, if the electron jumps from higher energy orbit to lower energy orbit, energy is released. And that energy is calculated by using the formula delta E is equal to E2 minus E1, because this H and H gets cancelled. So simply delta E is equal to E2 minus E1 when the electron jumps from higher energy orbit to lower energy orbit. So delta E is equal to, that is change in energy, is equal to E2 minus E1, and in this case energy is absorbed. Similarly, if the electron is jumping from lower energy orbit to higher energy orbit, then delta E is equal to, in this case energy is absorbed, delta E is equal to E1 minus E2. E1 minus E2, energy is absorbed, and in this case energy is released. First case energy is released, and second case energy is absorbed. Here in this case energy is released, and in this case energy is absorbed, and in this case energy is absorbed, where E1 and E2 are energies of higher energy and lower energy states respectively. So as long as the electron revolves in the same orbit, there is no loss or gain of energy. Only when the electron jumps from higher energy orbit to lower energy orbit, or lower energy orbit to higher energy orbit, energy is being radiated, and that is based upon that change in energy is calculated by using the formula delta E is equal to E2 minus E1, or frequency is equal to delta E by H. I hope it is clear for you. Next. So the expression for energy of electron in nth Bohr orbit is given by, the expression for energy of electron in nth Bohr orbit is given by this principal formula, very very important. That is minus 2 pi square z square me power 4 k square by n square h square. So this is called the principal formula. Principal formula means exact formula. Anyway, this formula will not apply for finding the numericals, but this is very, very important. And here En is called energy of electron in the nth orbit. Z is called atomic number. Z is called atomic number. Hydrogen atomic number is 1. So Z is called atomic number. And M is called mass of electron. N square, H square. N is called orbit number. H is called. So where K is equal to 1 by 4 pi epsilon naught. So this is the exact formula for finding energy of electron. That is K is called 1 by 4 pi epsilon naught. That is also called as permittivity of phase space. Permittivity of phase space. So this is the exact equation for energy of the electron in the nth orbit. But this is the only the formula, but application formula is different. That is En is equal to minus 2.18 in 10 to the power of minus 18 into 1 by n square. That is z square by n square. Actually here we should write for hydrogen-like species. So here we can write z square by n square because hydrogen-like species we have to consider also. So this is the expression. In this case it is joules per atom. Now because how we got this value? Because pi is constant, z is constant, mass of electron is constant, E also constant, K is also constant, H is also constant. By applying all this, by after calculating we got this value, that is minus 2.18 in 10 to the power of minus 18 z square by n square. This is the application formula. If they ask the energy of electron in the nth orbit in joules per atom, you have to use this formula. And instead of this, if they ask the energy of electron in nth orbit in electron volts, we have to use another formula. So that formula I'm writing here. Energy of electron. So moving to previous slide. So here energy of electron in electron volts. So En is equal to energy of electron in nth orbit. En is equal to minus 13.6 into z square by n square for hydrogen and hydrogen-like species. Electron volt per atom. Electron volt per atom, because they'll give electron volts also in the answer. So if you want to calculate energy of electron, that is 13.6. It is 18. It is 13.6. And joules per atom, you have to use this formula. Z is common. Here Z I have not written, but here Z square is common. That is hydrogen spectrum. Since hydrogen atom Z is 1, that's why we'll not consider Z. But if you take hydrogen-like species, then we have to substitute Z value also. So this formula is most important. The principal formula, application formula, both are very, very important. This is called the principal formula, and these two are called application formulas. Depending on the question, you have to substitute the formulas. So this is very, very important to find expression for energy of electron in nth orbit. Next, significance of negative sign in energy expression. Why we are using negative sign? Very, very important. When the electron is at infinite distance from the nucleus, it will not have any influence on the nucleus. Hence, its energy is infinite at distance. At infinite distance is 0. As the electron approaches towards the nucleus, the attractive force starts predominating, and hence the energy of the electron goes on decreasing. As the electron approaches nucleus, the attractive forces start predominating, and hence the energy of the electron goes on decreasing. Thus, the energy of electron in any orbit is negative. This is the significance why we are using negative sign. So, next. Now, apart from this, Bohr also successfully calculated the radius of nth orbit, and the exact expression for radius of nth orbit is the expression for nth orbit is the principal formula, which is very bigger. And after calculating, we can make it short. So n square h square by 4 pi square m z square k. So z is called atomic number here. So remaining all the constants, and n is also not constant, so that is orbit number. So the simplified formula for radius of any orbit in hydrogen is given by a into n square by z, n square divided by z for hydrogen and hydrogen-like species. So this is measured in angstroms, a naught. So a naught is equal to 0.529 because n square h square, after calculating all these constants, we got 0.529 into n square by z. So the final option, final answer is 0.529 into n square by z. And for the first series of first Bohr orbit of hydrogen atom, because z is 1 square, so it is 0.529 angstroms. So final answer is 0.529 into n square by z is a formula, or 0.53 also you can use by z for hydrogen and hydrogen-like species. In this way you have to use, this is the application formula, this is the application formula, and this is the principal formula. So I hope this is clear for you. So this is radius of nth orbit and radius of orbit, nth orbit of hydrogen atom. Now similarly, he also calculated velocity of electron in the nth orbit. So the expression for velocity of electron in the nth orbit of atom is v is equal to 2 pi z square k by nh. Here z by n is not constant, remaining all are constant. So by substituting these values, we got velocity is equal to 2.18 or 2.19 10 to the power 6 into 1 by n. In place of 1, you have to write z, because z for hydrogen is 1. That's why you have kept it there 1. But actually, for hydrogen like species like helium, ion, beryllium, and etc., we have to use that value, that is atomic number. So this is formula for finding velocity of electron in the nth orbit. All these formulas are very important for board objective exams. So to find velocity of electron in the nth orbit, you have to use the formula 2.18 or 2.19 10 to the power of 6 z by n meters per second. I hope this is clear for you. So Bohr successfully calculated radius of an orbit, energy of electron in the nth orbit, and also velocity of the electron in the nth orbit. Now, what are hydrogen-like species? So he could explain the not only hydrogen spectrum but hydrogen-like species. That is most important. That's why I wrote here there itself. You can see here now. Hydrogen-like species are the ions having one electron only, but more number of protons in the nucleus. For example, if you take helium, helium contains 2 electrons because atomic number of helium is 2. If you remove 1 electron, then it becomes helium plus. So then it becomes helium plus, means it contains only 1 electron. So all these are called single electron species. Single electron species like hydrogen. Lithium plus 2 also. If you take lithium ion also, lithium plus 2 ion, only lithium contains 3 electrons, but lithium plus 2 ion means 2 electrons are gone, so only 1 electron is left. That's why these are all called as single electron species like hydrogen. So lithium ion plus 2, beryllium plus 3 ion, etc. But in this case the atomic numbers are not similar, because for lithium it is 2, for lithium it is 2, no sorry, for helium it is 2, for helium the atomic number is 2, lithium it is 3, beryllium is 4. So in place of Z, we have to use 2, 3, and 4 respectively, depending on the atom. So the expressions of energy, radius, and velocity of electron-like species can be changed into minus 2.18 10 to the power minus 18 into z square by n square. R is equal to a naught into n square by z, and v is equal to 2.1 10 to the power of 6 into z by n. This is for hydrogen, not only for hydrogen, but also hydrogen-like species. So, and one more formula also I have given in terms of electron volts. En is equal to energy of electron in the nth orbit. En is equal to minus 13.6 by n square into z square in case of electron volts per atom. So electron volts per atom. So all these other application formulas for finding radius of nth orbit, energy of electron in the nth orbit, and velocity of electron in the nth orbit. So these three formulas are most important for all competitive exams. Definitely they will get question. You will get question from these formulas. So next, if the second Bohr orbit has a radius of 2.21 10 to the power minus 10 meters, what is the radius of fourth Bohr orbit? So second Bohr orbit is given. So Rn is equal to 0.53 into n square by z. That is in angstroms. So they have given in meters. First we'll find the angstroms, then we can convert them into meters. So because 1 angstrom is 10 to the power minus 10 meters. So first we'll find the value in angstroms. So fourth Bohr orbit they're asking 0.453 into 16. 0.53 into 16 by z value, because it is only hydrogen atom. So 0.53 into 16 is equal to 8.48. Is 8.48 angstroms, which can be written as 8.48 into the power of minus 10 meters. 8.48 into 10 to the power of minus 10 meters. In this way, you have to calculate radius of nth orbit. So second orbit only for reference they are given, but no need to consider that value. Straight away radius of fourth orbit we can find, because 0.53 angstroms into n square by z is the formula. N square is nothing but fourth orbit. 4 square is 16. So 0.43 by 16 into 16 by 1. Z value is 1 because hydrogen atom they have not specified, but Bohr orbit means hydrogen atom they have specified. So it is nothing but 8.48 angstroms, and which is also called as 8.48 10 to the power minus 10 meters, because the answer is given in meters. So I hope this is clear for you. Now I'm giving the answer. So 8.48, actually it should be into 10 to the power of minus 10. 8.48. Next question. What is the ratio of velocity of electron first orbit of hydrogen atom to the velocity of light? So velocity of light. First we'll find the radius of electron. Velocity of electron, that is 2.18 in 10 to the power of 6, 2.19. 2.19 velocity of electron is equal to 2.19 into 10 to the power of 6 is the velocity of electron in the first orbit, because n is 1, divided by ratio they are asking. So divided by velocity of light 3 in 10 to the power of 8. So 3 in 10 to the power of 8 meters per second. So by substituting this, you can get the answer clearly. After substituting this, you can simplify that. So then you got the answer. V1 by Vt is equal to 7.26 into 10 to the power of minus 3. He has taken V1 as velocity of electron in the first orbit. Straight away you can use that formula, 2.19 10 to the power of 6 or 2.18 in 10 to the power of 6. And V2 value is, already we know, velocity of light is 3 in 10 to the power of 8 meters per second. So by substituting this, you will get the answer 7.26 into the power of minus 3 by simplification. So I hope that simplification you can do. Next, example 3. Calculate the energy of electron in the third orbit of lithium ion. What is the radiation velocity of the electron in this orbit? So they are asking all the three. Energy of electron in the third orbit of lithium ion. In electron volts, I am calculating now. So energy of electron, En is equal to, first I am writing formula for energy of electron. First point, En is equal to minus 13.6 into n square. N square here it is what? Third orbit, so 3 square. So that is 3 square by lithium ion. Z square into, sorry, Z square is minus 13.6 by n square, that is 3 square. 3 square here itself. So again, I'm writing the formula for your recap. So minus 13.6 into 3 square by this square, because minus 13.6 into Z square by n square. Z square for lithium ion, atomic number of lithium is 3. So 3 square by 3 square. So 3 and 3 gets cancelled, that is equal to minus 13.6 electron volts. So simple, it is minus 13.6 electron volts. If they are asking joules per atom also, you can write. Next, what is the radiation of the electron? So radius means Rn is equal to 0.53 into n square, that is 3 square, by z value, that is 3. So 1 3 will get cancelled, 0.53 into 3. So 0.53 into 3, the answer is 1.59 angstroms. 1.59 angstroms. And third one, velocity of electron in this orbit. Velocity is equal to 2.18 or 2.19 in 10 to the power of 6 into n square, that is 3 square, by z. By z value is 3. So 1 3 also will get cancelled. So 2.19 into 3. So 2.19 into 3 comes around 2.19 into 3 is equal to 6.57. So final answer is 6.57 into 10 to the power of 6 meters per second, because velocity unit is meters per second. So these formulas you have to apply, simple. So I hope this question you understood. Now we'll check the answers. So they have given, because energy is 13.1, 13.6 only we got in electron volt. So here they have given in joules, that is 2.18 into the power minus 18 into z square by n square. Z square is 3 square, n square is also 3 square, both get cancelled. Velocity is 2.19 10 to the power of 6 meters per second, and radius is 1.587 10 to the power of minus 10 meters per second. And velocity value by z only it is, but it has taken z square. So this velocity value is wrong. It is 6.1, 6.57 10 to the power of 6. Next topic. So these numericals are clear. More numericals we'll do after this session. At the end of the session, more numericals we'll do. So explanation of line spectrum by Bohr's theory. Explanation of line spectrum by Bohr's theory. When energy is supplied to hydrogen gas, different hydrogen atoms will observe different energies, and the electrons are excited to higher energy orbits. So in higher energy orbits, these are unstable and they return to their ground state by emitting radiations. So yesterday we discussed about, in the previous class we discussed about line spectrum and band spectrum. Same way here also. The energy is supplied to, when some energy is supplied to hydrogen gas, the different hydrogen atoms will observe different energies and the electrons are excited to higher energy orbits. In the higher energy orbits, as they are unstable, they return to their ground state by emitting radiations. If the electron jumps from any of the higher energy orbit to first orbit, thus a series of spectral lines are formed, which is called as Lyman series. So, in the previous session, we explained about hydrogen spectrum, and this is the explanation of hydrogen spectrum by Bohr's theory. So, how Bohr explained this hydrogen spectrum? If the electron jumps from higher energy orbit to lower energy orbit, that is first orbit, the series of spectral lines is formed, and a series of spectral lines is formed, which is commonly called as Lyman series. Similarly, if the electron jumps from higher energy orbit to second orbit, the series of spectral lines is formed, obtained, is called Balmer series. This is formed in visible region. The infrared region, visible region, ultraviolet region. First, Lyman series is an ultraviolet region, and the Balmer series is in infrared visible region. Next, if the electron jumps from higher energy orbit to third orbit, the series of spectral lines obtained is called Paschen series. Similarly, if the electron jumps from higher energy orbit to fourth orbit, the series of spectral lines formed is called bracket series. And if the electron jumps from higher energy orbit to fifth orbit, the series of spectral lines is obtained as P-Fund series. So this I have shown the diagram also. Next we are going to see the diagram of this. Clearly you can see here. So if the first one you can see the Lyman series, the electron is jumping from n is equal to infinity or n is equal to 7. N is equal to infinity, that is higher energy orbit, to n is equal to 1. See, all these lines are coming from n is equal to 7 to n is equal to 1. So this series of lines are called as Lyman series. Next, if the electron jumps from any of the higher energy orbit, that is n is equal to 7 or infinity, to n is equal to 2, means here the landing is n is equal to 2, they are called as Balmer series. Similarly, if the electron jumps from any of the higher energy orbit to n is equal to 3, it is called Paschen series, bracket series, and Fund series. So these are emission spectrum of hydrogen atom explained by Bohr's theory. So when the hydrogen atom is given some energy, the electrons in it will jump from higher energy orbit, will jump to absorb that energy and goes to higher energy state. As they are unstable over there, they tends to fall down. And the falling can be done by many ways. So some of the few ways are, if the electron jumping from higher energy orbit to the n is equal to 1 orbit, that is first orbit, that is n is equal to 1 is K shell, that is K orbit. N is equal to 2 L shell, n is equal to 3 M shell, as I already told you. So n is equal to 1 K shell. The series of spectral lines is formed, that is 721, 621, 521, 421, 321, and 221. These are the possible jumpings. That is 721, 621, 521, 421, 321, and 221. 121 cannot go. So these spectral lines are called as Lyman series. Similarly, if the electron jumps from any of the higher energy orbit to n is equal to 2, that is 722, 622, 522, 422, infinity to 2, and 322. So a series of spectral lines are found, which are found in visible region, and these are called as Balmer series, and like that Paschen, bracket, and funds. I hope this diagram is clear for you. Next. deviation of Rydberg's equation from Bohr-Say. If the electron undergo transition from high energy orbit to low energy orbit, then the energy of emitted photon is equal to the difference in energies of these two orbits. So delta E is equal to E2 minus E1. So E1 is equal to RH by 1 by N2 square minus RH into 1 by N1 square. And delta E, by this you can write delta E is equal to RH into 1 by N1 square minus 1 by N2 square. That is change in energy without Z. And E is equal to h nu, since already you know RH into 1 by N1 square minus N2 N square, and nu is equal to RH by h, that is h is Planck's constant. And in terms of wave number, we can write nu is equal to nu bar is equal to nu by c. So RH by hc into 1 by N1 square minus N2 square. So by substituting these values, we got finally Rydberg's constant value RH into 1 by N1 square minus 1 by N2 square meter inverse, and the Rydberg's constant value R is equal to 1.09677 into 10 to the power of 7. That is the value of Rydberg's constant in meter inverse into 1 by N1 square minus 1 by N2 square. Next, in this case, you see here, E is equal to h nu, RH into 1 by N1 square minus 1 by N2 square. So RH value we already know, and in terms of wave number, you can write the formula RH by hc. By substituting these values, you will get the value. Only RH will be left over. Remaining all they have calculated because they are all constants. So nu is equal to 2.18 10 to the power of minus 18 by 6.62 by 10 to the power of minus 34 is Planck's constant value into 3 10 to the power of 8 is velocity of light. So by calculating these values, finally we got RH value as 1.09667 into 10 to the power of 7 into 1 by N1 square minus 1 by N2 square. Next, calculate wavelength and energy of radiation emitted for the electron transition from infinity to the ground state of hydrogen atom. Ground state means N is equal to 1. And wavelength, they are asking us to find energy and radiation emitted for the electron transmission. So to calculate wavelength, by using Rydberg's equation, energy of radiation also by using that is 2.18 10 to the power of 18. And you can use the wavelength, energy and radiation emitted for the electron transition from infinity to the ground state of hydrogen atom. Ground state means N is equal to 1. So you can use the formula wavelength is nu bar is equal to, nu is equal to, that is 1 by lambda is equal to nu bar. Nu bar is equal to 1 by lambda, which is equal to RH into 1 by N1 square minus 1 by N2 square. So in this case, N1 square is nothing but ground state 1 square, and N2 is infinity. And energy in the first orbit also we can find out directly, minus 13.6 by N square. So after that, you'll get the answer. So nu bar, you know how to find out. So I hope this is clear for you. The answer is given here, 91.1 nanometers. That is the wavelength and energy of radiation emitted for the electron transition from infinity to the ground state of hydrogen atom. Next question. What is the frequency and wavelength of photon emitted during the transition from n is equal to 6 to n is equal to 2? First, we can find wavelength. After that, we can find frequency. So how to calculate wavelength? By using Rydberg's equation, 1 by lambda is equal to, that is nu bar is equal to 1 by lambda is equal to RH into, that is 1.097 into 10 to the power of 6, 1 by N1 square, that is 6 square, sorry, 2 square, because N1 is smaller, N2 is bigger. So 1 by 2 square minus 1 by 6 square. After finding nu bar, we can find frequency nu is equal to C into nu bar. So if you multiply for nu bar C, that is velocity of light, you will get the value of frequency. So in this way, you can find frequency and wavelength of photon emitted during the electron transition from n is equal to 6 to n is equal to 2 state in hydrogen atom. So these formulas, after calculation, you will get the answer. I hope this you can understand. So I'm seeing the answer now, showing the answer. You can verify it. Wavelength is equal to 410.6 nanometers and frequency is equal to 7.30 10 to the power 14 second inverse. Next question. Calculate the wavelength in angstroms of the photon that is emitted when the electron in Bohr orbit n is equal to returns to the orbit n is equal to 1 in the hydrogen atom. So here also the same thing. Wavelength in angstroms they are asking. that is emitted when the electron is jumping from second orbit to first orbit. So same formula, nu bar is equal to 1 by lambda. Nu bar is equal to 1 by lambda. I'm writing it on the screen. You can just see. So these models are most important. Rydberg's equation nu bar is equal to 1 by lambda, which is also equal to RH into 1 by n1 square minus 1 by n2 square. And hydrogen atom, now we have to take Z. If Z is involved, then RH into Z square we have to write. RH into Z square. That is most important. So after calculating, you will get the value of lambda in centimeters or meters. You can convert them into angstroms by multiplying with 10 to the power of minus 8. So this simplification you can do. So the answer for this question is 11211. So that is 1221 angstroms. That is 1221 into 10 to the power of minus 8 centimeters. Next, very important. This page is very important. This slide. How to calculate number of spectral lines in the hydrogen spectrum. So how many spectral lines will be formed? That can be decided by using this formula. When the electron jumps from higher energy orbit to undergo transition of the ground state n is equal to 1, then number of spectral lines is equal to n into n minus 1 by 2. Simply higher energy level undergo transition from ground to the ground state. Means if they don't specify any, just ground state they said. No need to specify ground state n is equal to 1. They said ground state. Suppose then you have to use this formula n into n minus 1. For example, calculate the number of spectral lines when the electron jumps from fifth orbit to ground state. Then 5 into 5 minus 1 by 2. That is n into n minus 1 by 2. And is taken as 5 into 5 minus 1 by 2. So 5 into 5 minus 1 is 4. 5 4 is 20 by 2. It is 10. Like this you have to do that question. Suppose instead of giving ground state, if they have given lower orbit number also. Means find the number of spectral lines formed emitted when the electron jumps from fifth orbit to second orbit. Instead of giving ground state, if they have given second orbit, then you have to use this formula n2 minus n1 into n2 minus n1 plus 1 by 2. For example, I am solving this question here. Suppose if the electron is jumping from fifth to second orbit, the electron is jumping from fifth orbit to second orbit. So n2 is equal to 5. I'm writing here, you can just see, applying the formula. Instead of n2 is equal to 5 and n1 is equal to 2. Here they didn't mention ground state. If they mention ground state, no need to take n1 value. So you can use this formula. But here they have mentioned n1 is equal to. So now we are finding number of spectral lines is equal to 5 minus 2 into 5 minus 2 plus 1 by 2. So 5 minus 2 is 3. 3 into 5 minus 2 is 3 plus 1, 4 by 3 into 4 by 2. So it is 2 times. So it is 6 spectral lines. So answer is 6 spectral lines. In this way you have to solve this. These two formulas are most important. When you will use these two formulas, suppose if the electron is jumping from any of the higher energy orbit to the ground state, you have to use straight away n into n minus 1 by 2. And in this case, n value is higher energy orbit number. Suppose fifth energy, sixth energy, like that. Simply, if you use second formula, when you will use, if the electron undergo transition from higher energy orbit to lower energy orbit, means they will mention lower energy orbit instead of ground state, they will say lower energy level. Lower energy level means from 5 to 2 or 6 to 2, 6 to 7, 7 to 6, like that. So you have to use the formula like this. So in this way, you can find out number of spectral lines. So calculation of number of spectral lines in hydrogen spectrum is clear. These two formulas are most important. So note down these two formulas in your classwork. Next, what is ionization energy of hydrogen atom? You know ionization energy means the energy of the electron. So here, the amount of energy required to remove the electron from the neutral gas atom is called ionization energy. So ionization energy of hydrogen atom is the energy required to remove the electron from n is equal to 1 to orbit to n is equal to infinity. So this is called hydration energy and is used as delta E. Delta E is equal to 2.18 10 to the power of minus 18 joules per atom. Our ionization energy is called 1312 kilojoules per mole. This is very important. So ionization energy is nothing but energy of electron in the nth orbit. So I hope this is clear for you. Next. Now, calculate the maximum number of spectral lines obtained when n is equal to 6 undergo de-excitation to ground level. See here they have mentioned only ground level and the number of spectral lines you have to calculate. So when they have mentioned ground level n is equal to 1, they will not mention, simply they will say ground level. So in this case n into n minus 1 by 2. The formula is number of spectral lines is equal to n into n minus 1 by 2. That is 6 into 6 minus 1 by 2. So 6 into 5 by 2, that is 30 by 2 is 15. 15. Number of spectral lines is 15. So this is clear. Next. Yes. Answer is also 15. Next question. Calculate the number of spectral lines obtained in hydrogen spectrum when the electron jumps from higher energy level n is equal to 8 to n is equal to 4. They have given n is equal to 8 to n is equal to 4. For this, the formula is n2 minus n1 into n2 minus n1 plus 1 by 2. Because they have mentioned lower energy orbit number, that is not ground state, is n is equal to 4. So by substituting this formula, you'll get the answer. N2 is equal to 8, n1 is equal to 4. So 8 minus 4 into 8 minus 4 plus 1 by 2. So it is 4 into 8 minus 1 is 4 plus 1, 5 by 2. 20 by 2, it is 10. So I hope this is clear for you. Answer is 10. So these two formulas are most important for the competitive point of view. They will get questions like this. Next, what are the merits of Bose? Already we discussed. Bose successfully explained the origin of lines in hydrogen spectrum, the values of Rydberg's constant, and frequency of spectral lines in hydrogen spectrum calculated from Bose theory are in agreement with experimental values. Next, also he could successfully explain the energy of electron in the nth orbit. He could successfully explain the energy of electron in the nth orbit, and also he could successfully explain the radius, calculated radius of nth orbit, and also he could successfully calculate the velocity of electron in the nth orbit. So these are all the merits of Bose theory, and most important is he could successfully explain the spectrum of hydrogen atom and also hydrogen-like species, that is single electron species. So these are all the merits of Bose theory. Next, limitations. What he could not explain. Bose theory fails to explain the spectra of multi-electron atoms. It could not explain the fine structure of lines in the spectra obtained by using spectroscope with high resolving power. It does not explain splitting of spectral lines in magnetic field and an electric field. So why the electric spectral lines are getting splitted when the electric field is introduced and magnetic field introduced, that is Zeeman effect and Stark effect, he could not explain. And Bose theory violates Heisenberg uncertainty principle. What is Heisenberg uncertainty principle? This next topic we'll discuss. And so he could not explain spectra of multi-electron atoms. Already I told you he could explain only hydrogen spectrum and also hydrogen-like species. And he could not explain fine structure of lines in spectra obtained by using spectroscope with high resolving power. And he could not explain splitting up of spectral lines in magnetic field. Now, next. We are giving slide here, some homework. You just work out all these questions. I'm just giving the questions for this today's class, for this lecture. So question number 1. Question number 1, just write down. I'm writing it on the board. According to Bose theory, in hydrogen spectrum, according to Bose theory, in hydrogen spectrum, the spectral line of Balmer series having lowest wavelength is the spectral line of Balmer series having lowest wavelength is the spectral line of Balmer series having lowest wavelength is first option H alpha line. having lowest wavelength is? First option H alpha line. Second option H beta line. Beta line is second line, alpha line is first line. That is Balmer series means N1 is equal to N2 is equal to 3. So alpha line is 3 to 2, beta line is 4 to 2, and so on. And next gamma line 5 to 2. H gamma line. And fourth option H limiting line. So they're asking which is having lowest wavelength. So already we know for limiting lines they have highest frequency and lowest wavelength. So answer is H limiting line. H limiting line is having lowest wavelength and highest. Next question. So homework is given. It means here you are supposed to write in your classworks and do it. Next question. The energy of electron of hydrogen atom in the second orbit is the energy of electron of hydrogen atom in second orbit is minus 3.41 electron volts. Second orbit is minus 3.41 electron volts. The energy of second orbit of helium ion would be the energy of second orbit of helium ion would be, here it is helium ion. I'm writing it again. Yes. So first option minus 0.85 electron volts. Here they are given answer in case of electron volts. Minus 0.85 electron volts. Second option minus 13.6 electron volts. Third option minus 1.70 electron volts. Minus 1.70 electron volts. And fourth option minus 6.82 electron volts. Let us solve this question. So energy of electron in the second orbit of helium ion. Straight away, instead of using that value, straight away we can say energy of electron E is equal to minus 13.6 by n square divided by n square into z square. N square into z square. So you know helium ion is 2. So that is equal to minus 13.6 by 2 square because second orbit, and atomic number of helium is 2. 2 square gets cancelled. So answer is minus 13.6 electron volts. So like these questions they ask in the examination. Next question. The ratio of radius of second orbit and third orbit of hydrogen atom is. The ratio of radius of second orbit and third orbit of hydrogen atom is. So first option 3:2. Second option 9:4. Third option 2:3. And fourth option 4:9. Third option 2:3. And fourth option 4:9. So answer could be R1 by R2 is equal to R1 by R2 is equal to small r1 0.53 into, you know the formula, that is n square. N square is here second orbit, so 2 square by 0.53 into 3 square, because fourth orbit, third orbit. So 0.53 gets cancelled. So it is 4/9. Answer is 4:9. So fourth option. So this is clear. Next question. The initial energy of the ground state of hydrogen atom is the initial energy of the ground state of hydrogen atom is 2.18 in 10 to the power of minus 18 joules. 2.18 in 10 to the power of minus 18 joule per atom.
10 to the power of minus 18.
10 to the power of minus 18 joules. The energy of electron in its second orbit will be, the energy of electron in its second orbit will be, first option minus 1.09 10 to the power of minus 18. First option minus 1.09 into 10 to the power of minus 18. Second option minus 2.18 10 to the power of minus 18. Second option minus 2.18 10 to the power of minus 18. Third option minus 4.36 in 10 to the power of minus 18. Fourth option minus 5.45 in 10 to the power of minus 19. Minus 19. So how to calculate this type? Because they are given ionization energy, that is energy in the ground state is given. The energy of electron in second orbit. So E is equal to, so minus 2.18, that is En by n square. En by n square. Minus En by n square. Where En is called ground state. So here that is minus 2.18 in 10 to the power of minus 18. That is the energy of electron in the ground state is given already. Divided by n square. That is n is second orbit 4. So here n is equal to second orbit. So I'm writing it here directly 4. So after calculating this, you'll get it as minus 5.45 in 10 to the power of minus 19 joules. Minus 5.45 in 10 to the power of minus 19 joules. So answer is fourth option. So I hope this clear. So in this class, what we discussed Bohr's postulates and demerits as well as Bohr's theory, hydrogen spectrum, etc. So in this case, in this class, this lecture is very, very important because you'll get questions based on energy of electron in the nth orbit, radius of nth orbit, and also velocity of electron in the nth orbit. So all this is clear. Very, very important class this is. So practice what I said. So I'm ending this meeting now.